so we are going to cover 2 chapters today. The full text PowerPoints are available to you in week 2. Okay. What I have done is went through, I don't know, there's like 100 and some odd slides, and tried to simplify it into what I think are the most important things. Okay. Feedback that I got last summer, I guess last fall, was that you all kind of know about visualizations. You all kind of know about descriptive statistics. So my plan today is to go fairly quickly through this material. If you have a question, stop. Ask me. Okay? But I don't want to spend a lot of time. The mean is this. You add all the numbers up, divide by how many there are, assuming you got that in 6th grade, and you're good, right? So, Chapter 2 is more about the visual piece. Chapter 3 is more about the number crunching. So, Chapter 2, we're summarizing categorical data. Okay. Big ways that we can summarize categorical data are with frequency distributions, relative frequency distributions, percent frequency distributions, bar charts, and pie charts. So if we had some data, I made the data pretty small because it really doesn't matter what the data looks like and what the data are. So if we had some data, this happens to be a N, and we've asked the quality rating of, hey, what do you think about our N? They can choose from poor to excellent. Here are our ratings. The first gives us a frequency count. So we have 20 data points. We can look at the frequency count. Then we move on to a relative frequency. And what's the difference between a relative frequency and a percent frequency?
2 decimal places.
2 decimal places. That's it. You smooth the decimal, right? Instead of writing it as a decimal, you write it as a percentage. Okay. Some people can handle relative frequencies. Most of the time, you present things with the percent frequency. But the relative frequency is the step in between when you do the math. Okay. So to get that frequency, 2 divided by 20 gives us, that's where the 0.1 comes from. Do you like that tabular form of data? You got some information, you got some details. Would you rather see stuff like this or like this? With a bar graph, bar chart. Bar chart, right? That's great. I can tell all the same information, and it's pretty. I mean, it's black and white, it's not all that pretty, but, right? Okay. Or, I can turn it into a pie chart. What are your thoughts on pie charts?
Big fan.
I got a big fan of the pie chart. Our pie chart was better. Pie chart always better?
No.
No. In fact, there's a lot of people who are like, pie charts, no, stay away. When is it okay to use a pie chart?
The percentage.
When you have like a few categories.
Okay, so small, a relatively small number of categories. We got to be talking about some type of percentages. Can I just use any type of percentages, or is there a special kind that we want to make sure happens in a pie chart?
You have to add up to 100%.
They have to add up to 100%. Excellent, right? The only time you're using a pie chart is if you're really talking about a piece of a whole. Okay, if you're not talking about a piece of a whole, just because it's percentages, don't make a pie chart. You would be surprised. I have graded such things. I've graded pie charts that have about 100 different categories. Don't. Just don't. Okay. And I have graded pie charts that add up to more than 100%. Don't. Just don't. Okay? But in general, nice categorical data is pretty easy. When we move on to quantitative data, we can do a lot of the same thing. We still do frequency distributions, relative and percent frequency. We can also do cumulative distributions. We could have done cumulative distributions before. We can do a dot plot, a histogram, a stem and leaf plot. These are your classic Stat 101 graphics that you're never going to use again. do use histograms a lot. These other ones, not so much. So here I have a sample of 50 tune-ups. Took my car to the shop. Counted the cost of the parts for my tune-up. Okay. Same kind of idea. Frequency, relative frequency. My far column here now is a cumulative frequency. Why might a cumulative frequency be helpful?
Because if you wanted to know all the tune-ups that you had that were less than $90, like the percentage, that you don't have to add up all the relative frequencies, it's just right there.
And that's really the only time it's helpful. You could have just added up the numbers when you wanted to ask or answer the question, but that's what a cumulative frequency is for. Okay, because it just lets you answer things. It already has stuff summed up for you. So in the past example, it was pretty easy for what we used as our categories, right? Poor, below average, average. Those are our only options. Now we have values that go all the way from like 52 to like 109, I think. How did I choose these classes, these intervals? Do what?
They're evenly sized.
They are evenly sized, okay? Do you think that's important?
Yes.
Okay, so evenly sized is important. What else is important? Okay, so I'll have to figure out the number of data points that I have.
Contains the entire range of data points.
Yes, I don't leave anything out. I have to have the whole range. Okay, but my range goes from 52 to 109. So why did I start at 50? Why did I start at 52 and go from like 52 to 61? And then 62 to 70?
People like
It would have been the extra
tens,
number.
round numbers.
Round up. People like tens. I'm a mathematician, so this is very hard for me to say. People like pretty numbers, right? All numbers are beautiful, they're mathematicians, but people like pretty numbers. They like the tens, the fives, the twos, right? So even though we can go down a little bit to make it make more sense. Okay. Same reason it's a class size of 10. Let's see, what else? How come I didn't go from 50 to 54 and 55 to 60, all right, 59, 60 to 64? What would have happened if I would have doubled the number of categories? So I would have had too many rows, it's getting a little, I would have had, if we go over here to look at our histogram,
That's correct.
I would have doubled the number of bars. Okay. And in some cases, maybe it's a good idea. In this case, probably not. So we can take our information from our frequency table, we can put it over in a histogram. Everybody comfortable with the histogram? What about right above it? What about a stem and leaf plot? You know what a stem and leaf plot is? Oh yeah, they made me do this and I hated it. I had to do it by hand. You had to put all the numbers in order, and then the first stem on the left is the first digit, and all the things on the right are the second digit. Technically what it is the stuff on the right is the last digit, and the stuff on the left is all the other digits. Right? So 52, 57, 101, 104. So if you take the stem and leaf and you flip it upside, give it like a 90-degree turn, what do you get? Oh, we get our histogram. But it has more information because I can tell, right? So if I look at, let's see what's a good one. Let's look at this right here. If I look at this bar, can I tell, do more of my tune-ups cost $90, like the low 90s or the high 90s? Can I tell?
No.
But if I look here,
High 90s.
high 90s. So the stem and leaf plot does give us a little bit more information. But would you ever present a stem and leaf plot? No. Visually, no, right? So that's kind of one of those things. We may not present the spaghetti graph, but we're going to use it to get insight. We would never present a stem and leaf plot, but we could use it to get better insights. The other fun one we have is the dot plot in the middle there, and it's really just a dot for every observation. What it is. Like, think about when you were little, and you had like, here's my line, and I know, I'm trying to ignore the guy walking on the ceiling. Stopping. So you just make little X's everywhere you have a point. That's what you're doing here a little. Dot plots. Histograms. Let's talk about histograms. Important. Some definitions. So everybody's good with a histogram itself. Let's talk about the shape of our histograms. So if we look at the top left, we'll start there. If we look at the top left, how would you describe the shape of that histogram? You guys all normal, these are big fancy words. I was looking for like bell shapes. Right, so it's a normal distribution, right? Everything's nice and good, it's symmetrical on each side, got this bell-shaped thing happening, life is good. So let's go to exam scores. Is it normally distributed? So we're going over to the right. So it's skewed. So it's skewed. Okay, I heard that word. Is it skewed to the left or skewed to the right?
Right.
How many say left? How many say right? How many aren't sure and are going to wait for more information?
I'm not sure anymore.
All right. So the way to tell which direction things are skewed. Anybody know? The tail. Which way is the tail pointing? Left. So we're skewed to the left because the tail goes to the left. And are we skewed a little bit? A lot? Somewhere in the middle? Just a little bit. Alright, so maybe you say a little bit, you say mildly. Have fun with your adjectives. Let's go down. What about executive salaries? Skewed to the left, skewed to the right? Skewed to the right. This side of the room knows. What about you guys?
Skewed to the right.
Skewed to the right. Alright, so the tail goes to the right, we're skewed to the right. Just a little bit, a lot. That's kind of high, alright? So we would say highly. Highly skewed to the right on that one. Does that make sense for executive salaries? A lot of executives, but there's a few that really make a difference. Alright, we'll try housing values. What about housing values? Skewed to the left, skewed to the right, normal? Skewed to the right. Still skewed to the right on this one. As the tail's going to the right. And how much? Moderately, maybe? Moderately. Sure. Moderately. Okay, so we've got skewness going on. Everybody happy with this? So right now we're just looking at it, we're identifying it. Later on, it will come to be important for us. What happens when we add in more than one variable? If we add in more than one variable, we've actually already talked about some of these things. You guys have drawn some of these things. The first thing we're going to talk about, well, here, is a cross tabulation. And it's going to have this thing called a Simpson's paradox in here. We've got scatter diagrams. We've also heard them called scatter plots, scatter charts. We've got the side-by-side bar chart and the stacked bar chart, which we've already kind of talked about. So a cross tabulation is really just taking two pieces of information, putting it in a one tabular format. Okay, so here we have two variables. We've got home style and we've got the price range. So we've broken it up by 4 different types of homes, 2 different price ranges, and we've got the frequencies hanging out in there. Depending on the question that we ask, we may want to find the percentages across the rows, or we may want to find the percentages across the columns to help better answer our questions. Right? So if we're going to talk about the price range, we might want to talk about our row totals, or our rows. Right? So in the lower price range, the split home style happens the most. Right? But if we're going to talk about home styles, we may want to be looking at the columns. So in the colonial column, there are more less expensive houses as opposed to more expensive houses. Okay? But I can't use these totals to answer that question. Right? So if I'm talking about the colonial houses, I don't want to use row totals because it doesn't, if we add this up, we've got what, 33 and 27? Looking at 50% here? Not 100%. So we don't want to be talking, if we're asking questions about home style, we want to use column totals. If we're asking questions about price range, we want to use the row percentages. Does that make sense? Finding the right summary of the right data to get the right answers. If I don't like that tabular form, side by side, we're in a stacked bar chart. It's getting that more information in there. If it's going to help me answer the question and it's not too busy, we're good to go. If we had 10 different price ranges, this may not be a good visualization. So given our data, given our business question, we get to choose the best visualization. Questions, comments, thoughts about graphical displays? Everybody good with the scatter diagram? Something on your x-axis, something on your y-axis. If we're going up into the top, what kind of relationship do we have? Yeah, you guys are so good. So down to the left or down to the right would be negative. And just a straight kind of horizontal line in the middle. There is no relationship whatsoever. Everybody happy? Good. All right. A few things to think about just when creating our effective graphical displays. Clear, concise. It says title, but it applies to the whole visualization. Keep it clear, keep it concise. And one thing it doesn't say is make sure it answers your question. Right? So keep the display simple, label your axes, make sure you use colors that you can differentiate between colors. Things you already know. I don't really like that. All right. That was chapter 2.